on the whole time. Too funny. Anyway, so there's going to be two kinds of integrals we work with, indefinite and definite. They have two very different meanings to them. So today is all going to be just about process, like how do you take when you won't know why you're doing it, but it's incredibly important. For example, how do you get from geometry the area of a circle? Pi r squared. Why? Because you were told, right? And so then you would be given an r, and they'd say, well, guess what, little Christian? The radius is 5, so what's the area? And you go 5 times 5 squared. But you didn't know why that worked. You get it right, correct? That formula comes from integration. Did you know that? So it's incredibly important. To all your geometry formulas that involve things with curvature, they actually come from an integration process. So we're going to talk about the biggest integration process there is, which is called U substitution. So let's take a look at this one right, sorry, it's moving my screen, right here. This could have been on yesterday's worksheet, right? I see you guys are super focused. That's helpful. It'll go really well if you are. I could have said this is doable yesterday because you could just FOIL that, right? And dump the 2x in and have a string of monomials and done them all separately because it would have been addition, right? But the minute I say to Clausen, okay, Clausen, use that for this, and I just make it 22. We would wait and the bell would ring and he probably still wouldn't be done multiplying that out, correct? And he'd have a huge string of monomials going all the way down the hall if I had him write it, because taking this to the 22nd power is horrendous. And then if I say, psych, I forgot a 2. Then we're here till tomorrow while he's sitting there. You see what I mean? Where U substitution does not get any more lengthy or difficult, even if I did 2,222 as my power. All right, and it also gives my answer in a much more user-friendly form. So I could have you do this, but I'm not. I want you to recognize something. First of all, we're going to look at what I call the inside function, the function that's in a function, which would be this x squared plus 1. So when I talk about the inside function with U substitution, I'm talking about who's an inside function. If I had a Calc 2 student, I should have had foresight and had somebody just randomly show up and say, hey, how would you integrate this? They'd immediately look at it, and even though they know about 8 or 9 techniques right now, they would say U sub, because what they would do in their head is they would grab the inside function, they'd take its derivative. The derivative of x squared plus 1 is 2x. And they'd quickly notice that they got the outside function. They'd quickly notice that when they did the derivative of this, they got the rest of the integrand. They know that they don't have to get the rest of it, but they have to get a multiple of it to use U sub. Did you hear what I said? They have to get a multiple of it. So had this been an x squared, U sub can't work. Something else might, but it can't be U sub because I've got a 2x and I need a 2x squared. Does that make sense? Now, had it been a 4x, then it falls into that multiple of it rule. See what I mean? So the derivative has to be, this stuff over here has to be a multiple or exactly the derivative of the inside function. If it's not, some other technique has to be applied to integrate it. Or maybe you can't find it. There are functions that have no antiderivatives. All right, so are you good with that? U sub works, and it's going to work on your entire assignment today and all day long, but I'm going to tell you why. It's because the derivative of our inside function is going to be living in the rest of the integrand. So take a look at this. What we're going to do is what's called a variable change. So I'm going to go rewrite that problem, and I want you to right over here. So as x squared plus 1, quantity squared, so go ahead and write that. And then it was a 2x dx right here. We're going to do a variable change. And the reason we choose U is because historically that's what the first people who did this process chose, so it just stuck. So it doesn't have to be called U sub, but it is. It could be called P sub if you want to use a P. It'll have the same net result, but U works. So we're going to let U equal that inside function. So go like this. You're going to go over here and you're going to start rewriting the integrand. So I'm going to call this U squared. And then just stop. If I wrote the rest of it, I would be writing U squared 2x dx. That's a huge no-no. If you look at the title of our book, can you see it down there, Clausen? It says calculus of a what? Single what? variable. You can't have two variables running when you have Calc 1 and Calc 2. Calc 3 will start mixing variables, but then they do double integrals. So there's an issue here in that we are calculus of a single variable. I cannot integrate u squared 2x dx. It can't fly. You need to have the exact same variable. So here's how you counteract that. You take the derivative of u with respect to x. So my du dx would just be twice x. That's pretty straightforward, right? Now, last chapter I said when we're looking for this differential, we just multiply by that denominator. And I think it was Devin who said, why am I doing that? Wasn't that you? Somebody in here said, I don't know why I'm doing it. I said, I'm trying to prep you for something later. So it doesn't seem so weird that we're multiplying that over and just looking for the top of it. The reason we just want the top of it is we need only u's in here. So watch what I'm allowed to do. This whole chunk of stuff is this whole chunk of stuff. So now I've done what's called a variable change. I can integrate x squared dx. It's x cubed over 3. I can integrate theta squared d theta. It's theta cubed over 3. Well, when we integrate now, we can integrate with u being our variable, and we'd say it's u cubed over 3. Guess who else we need? What else do you think I need to do now that I've taken my antiderivative? Yep, my Carl, my C, so go ahead and tack that on. You're not done though, because you'll notice the problem, the variable in the problem wasn't you. This is where I sometimes will say, if you quit here, I'll say this problem wasn't about you. I don't mean like y-o-u. I mean this problem wasn't a problem with the variable u. It had x in it. So we do what's called back substitution. Whatever you let your u be at the beginning can now, you're using it just so that you can integrate, and then you got to get rid of it, because you don't want your answer in terms of u. So this becomes x squared plus 1 quantity cubed over 3 plus c. Now, if I had to, how could I check it just to make sure? Like if I said, you better check that, this is our first one. What should happen to my antiderivative if I derive it? It should be equal to the original thing. Let's go try it. Now watch the rule I apply when I take the derivative. I bring the 3 out front, right? What's going to happen to it is that it's going to cancel with what's on, with what's on the denominator. So I'm going to end up with an x squared plus 1 squared times the derivative of the guts. That was the chain rule, correct? So the u sub is really the chain rule-ish counterpart in integration. It's kind of undoes it. So this guy right here, was it my original integrand? Yes, so I know I did it right. Now, had Caden said, you know what, I don't like it, and because I don't like that, it's new, it's weird, I'm just going to do it by foiling this and dumping the 2x in and do each piece separately. He would get the right answer. Correct? But again, the minute I make that 222, I'd say, good luck, Caden. You will see in a few days, right? But what would happen is down here, he would have had this in its stretched out form. Does that make sense? He would have had this guy right here with the whole top expanded. He would have had an x to the 6th plus, do you get what I'm saying? So not only is chain rule quicker, faster, and easier, its answer ends up being in the factored form, which makes it really nice. All right, we're not going to do this bottom part because this, again, sometimes I tweak the notes. Now, technically, we're going to go to the book right now. Your assignment's going to be 11 through 37 odd. We're going to talk about the evens and do enough of them until I get a good vibe. So like I said, first hour had 5 minutes left, second hour had 13. If I have to go to the end, I do. If we're done in 10 minutes, I'm fine. All right, so I'm going to go up here and just not finish any of these. That's why there's no workspace. We're just going to get a variable change. All right. I was very comfortable with your 4.1, so I think once we can get that variable change going, we'll be able to finish them pretty successfully. So I'm going to start, all right, I'm going to just ask Alejandro, in this scenario with number 12, according to what I just told you, granted it's our first one, so I'm sorry you're first, but I'm facing this way. So what's your U choice? Yes, for today, you might say, is it always the inside function? Go ahead and ask me that, Paige. today. So now ask me it again. No, just today. Okay? But most of the time. Sometimes it's going to be a denominator once we hit natural log stuff. That's going to allow us to help it out, help work with it. And sometimes it's going to be an exponent globally, like once we're done with the whole course. But for today, and most of the time in this chapter, it will be an inside function. Not always, but most of the time. So that's my u choice. Then I'm going to take its derivative with respect to x, and I'll get its derivative is twice x. Correct? Now remember, I want to replace all of this. So what did I tell you to do with the dx? Bring it over. You'll start not even putting the second step. You'll just write du equals 2x dx. Most people don't do that middle step, and I'm fine with it. Then you do a rewrite. So you go back up here and you say, okay, what do I actually have here? I have my u that's being cubed, and the whole rest of this is du. And I'll just go dot, 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 because this problem's not done. But on this page, I just want to talk about making a variable change. Correct? All right, we're going to skip to 16. I see people nodding. Something different happens though, so tune in if you're like, that was easy. It's so far it's pretty good. So who would my u choice be, Lindsay, for number 16? Yes, and maybe you want to start a rewrite right now and say, well, I've got u to the fourth. The problem is I'm sitting there with u to the fourth x squared dx. That's a calculus, that's the kiss of death when you start having calculus of multivariables. Guess what Calc 3 is called? Multivariable calculus. So you do not do that in Calc 1. All right, so we're going to go here, and we are going to say our u choice, as Lindsay chose correctly, is x cubed plus 5. And let's just see if we sort of have this variable change process down. Gunnar, what will I do with my u choice? Yeah, I'll do the derivative of u with respect to x, being my independent variable. So I will do du dx. Then you have to ask yourself a question right here. This is du dx. I'm just going to whip this over here. That's why we did it last time, Devin. That's why we were doing that. It seems stupid. We're just taking a derivative and whipping the bottom over, and you didn't get why you were doing it. By the way, you really don't get what this means in a real-world context yet either. Did you know? I'm just teaching you how to do it. Right? So we'll talk about that. Actually goes to a whole application with area and volume later, but for now it's just process. So let's go back over here. I have to look at the rest of this integral. I'm underlining it 5 times here. This is u to the fourth. This is not 3x squared dx. But that's kind of the beauty of math, is I can make it x squared dx. What do I just need to do? Divide by 3, and we're going to do its equivalent with multiplication instead. We're going to multiply by 1/3. I call it a 1/3 fraction correction that you're doing. That is not common language, though. That's like a little rude language. So if you start, like seniors, if you go on to Calc 2 and you say things like, don't forget Carl, like whoever you're working with is going to go, who? And if you go, don't forget St. Cloud, St. Negative Cloud, they're going to go, where? Like they live in Iowa, they have no clue, right? And if you say this has a 1/10 fraction correction, they're going to go, what's that? Because that's the rude language. So you got to be careful with what's low D high minus high D low, draw a line and square below. Yeah, that's out there, but that I didn't make that up, but it's not universally used. Does that make sense? And did you know product rule? What is it? First D second plus second D first. In most books, it doesn't come off like that. It goes D first, second, plus first, no, I can't even remember it because it doesn't flow off my tongue. It mixes them differently, but because it's commutative, so I do it the other way because it flows off your tongue, and it ends up with the same net result. So be careful. I'm going to call this a fraction correction, but that's not technically what it is. So watch what I'm going to do. I'm allowed to replace this whole thing with 1/3 du. All right, I'm going nice and slow today. Do you see what I'm doing? I'm doing an entire variable change. But instead of putting a 1/3 du right here, because we're eventually, and I got to tell you where we're going, we're eventually going to be working with numbers. They're going to be at the bottom and the top of this. It's going to be called a definite integral. It's going to represent volume and area, I mean. We're going to want the constant out front. So we put our fraction correction out front. Start it now, because eventually it's going to make your arithmetic, Elaine, way easier. Just get it out of the integrand. So that 1/3 du gets actually split apart. One in, one out. Then goes the dot, dot, dot. Okay, and you might say, I won't know what to do with the dot, dot, dot. You will. That's the next page of notes. So I want you guys to try until you go dot, dot, dot on, let's just do number 18. I just want to make sure you can do a variable change on a nice straightforward one. So number 18. Raise your hand when you're done or stuck on it. And only get it to the dot, 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 where you feel like you've got it ready to go in terms of you. It's not done, Christian, because the problem's not about you. Raise your hand when you've got it all in terms of you. I got 1, I got 2, 3, 4. And if you're listening to these notes, the 10 of you who are gone today, you should be trying this as well. All right, so let's go over to Abby. Who was your U choice? Perfect. Who's your DU? 10x dx. Is it what you want it to be, Paige? I don't want, see, you focus, so I don't even need to write. I love this class. Yes, I don't want it to be 10x dx. What do I want it to be? X dx. So what do I apply to it? A 1/10 fraction correction. Where do you put it? Out front. I'm loving it. All right, and then dot, dot, dot. So it should have looked like this. 1/10 the integral of u cubed du dot, dot, dot. How many of you had that? Awesome. So now we're going to talk about 2 other small issues, and then we're going to go do the dot, dot, dot. So this one is a little different, so monitor and adjust. What's different about this one? Well, square root and t's. Doesn't matter. We start it the same way. We're still going to do a pass off to u. We'll still let it be the inside function. It's the quartic under the root. So that's it. Now, I'm not doing du dx because x isn't my independent variable. What am I doing? Du dt. See, that's why we did it last chapter. I'm actually doing du dt is equal to t to the 4th plus 5. What do you think you're going to do here? The same thing we did when if you're not variable dependent, it won't get more difficult when I mess with the variables. What am I going to do at this juncture? Because I'm now sitting there with a root u, correct? What am I going, oops, I forgot to take the derivative. That's why you guys are staring at me so weird. 4t cubed, that was my fault. Is that why you guys were, I can see it on your face when you guys are so attentive, I can see it. You were looking at me funky, which I love. All right, now I'll repeat my question. Now what will I do? Multiply by what? dt. That's why we did that last chapter. If you don't want to show that middle step, that's fine. But I now have to decide if that's what I want. Sometimes it is, like on that first one. Sometimes it needs a correction. So I go back to the rest of the integrand and I focus on it and I ask myself, do I want 4t cubed? The answer is immediately no, and I correct it. With a what? A fraction correction of 1/4. Where did I tell you to put it? Out front, and boom, and then dot, dot, dot. Again, we'll fill in the dot, dot, dot later. Lastly, one like number 22 might mess with your head. It's the only time in the world that you can't do u sub. You have to choose a different letter of the alphabet. It's the only time. Only when in your integram, it is about you right now. So we need to make it about something else. What do you want to use? B? All right. So he wants to do B sub. We did W sub this morning, but Bo's weird. So we'll say you just have to pass off to a dummy variable. It's just traditionally, what did I say, was used. I didn't mean it that way. Oh, all right. So we're passing off to a dummy variable B. But now watch how I have to write this. I do need to take the derivative of B. Correct? I kind of like that you chose it because this looks weird. And if you have BD disease, this was a very bad choice, right? But this would be dB d what? du. So that independent variable's on the bottom. So that's kind of cool. So good. I like the choice of it, Bo. It kind of proves my point. It doesn't have to be u sub. It just is all the time unless this integrand is about u. So we're doing a b sub, so that means you're going to whip this over and now you'll do a rewrite. If you need to, you'll need to perform a fraction correction. Do I need one? Yes or no? Yep, sorry, 3u squared. I'm getting sloppy. I do. I need a fraction correction of a third. So how am I going to write this? This u squared du in the integrand has to be replaced with 1/3 dbo. Right? So here we go. On a rewrite, I have the square root of b. The rest of it is 1/3 db, and I would do it as normal. What do you think? The other thing I'm going to have you watch out for when you do your homework, which will be this similar, I'm just assigning the odds, watch out for one like number 32 because it's not u sub. And as you get more and more techniques, that's the tricky thing about integration is knowing which one to go to. This would not be a u sub go to. This is power rule. This is 1/2 x to the negative 1/2 dx. I do not need u sub to do that. It is a monomial. So that one would have been on yesterday's just fine. Now let's flip the page and we will go fill in the ... We're going to do one, I'll talk through one that doesn't need a fraction correction. Then I'll talk through one that does. Then I'll have you do one that's got some mess to it. If it goes well, we'll be done. If not, I'll do another one. All right? So this one up here, I'm going to go all the way through and just talk it on out. I won't ask you a single question. So u is my inside function. I immediately am going to start a rewrite of this. Correct? I'm going to call this u cubed. But as I said, we can't mix those variables. I can't have u cubed 2x dx. It's illegal. So I'm going to take the derivative of u with respect to x. du dx is twice x. So du would be twice x dx. At this point, you ask yourself, do you need a fraction correction? A lot of kids will put a half out front. You don't need it. Do you get why you don't need it for this one? This is the entire rest of the integrand. It needs no correcting. I can replace that whole boxed in expression with a du and I'm ready to roll. So now let's do the ... that we skipped on the other page. What is the antiderivative of x cubed dx? X to the 4th over 4. So what's the antiderivative of u cubed du? What will it be? U to the 4th over plus c. But we don't quit here because this problem wasn't about u. What variable was it about? Calculus of a single variable, my answer is going to be in a single variable, but not of u, x. So what did I say we do at the very end? Well, how am I going to get it back to x? Back substitute. You're going to take your original u choice as the inside function and put it back inside the function. So it becomes x squared minus 9 to the 4th over 4 plus c. All right? And if Robbie said, you know what, this isn't such a big power, I could do x squared minus 9 times x squared minus 9 times x squared minus 9, FOIL it, distribute, blah, 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 then dump a 2x in and do them all separately. He will get the right answer and I'll mark it right. But understand what he'll get. He'll get the expanded version of x squared minus 9 to the 4th. And it bugs me. And it's hard to grade, and it's a mess, and it takes longer. So I wouldn't do that anymore for this type of a problem. Next up, I want to talk about the check of it. How did we say you can check this? Take the derivative. What rule is u sub's counterpart? Chain rule will be done to check it. So watch. We'll do it real quick. I'll bring the power out front, so now I'm taking a derivative. It'll cancel with the denominator of x squared minus 9 cubed times the derivative of the guts. Notice the chain rule to my u sub got me right back to the original. What if it didn't bring me back to the original? I did it wrong. Exactly. So let's go try one that gets messier. I want it to have a fraction correction and some negatives in it. So I think I'm going to choose... I might as well go ahead here. So you guys seem to be getting it. I'll go to this one because it has a negative in it, and then I'm going to give you guys one to try on your own. All right? So first of all, you couldn't do this any other way. I said Robbie could choose to do that other one with yesterday's method, but this one you'd be stuck. You might say, well, I could FOIL the bottom. You will, but you won't have a heart that you can break apart. You'll have an upside down heart, and those can't be broken apart, so you'd get stuck. This is U-sub worthy. Again, I told you if Calc 2 walked in right now, they'd immediately look at that, and in all their 8 techniques I've taught them, they go, this is U-sub. If it wasn't, they'd try something else. But remember, for U-sub, we immediately locate the inside function, we take its derivative, and we hope it's the rest of it or a multiple of the rest of it. So I want you to understand why this is U-sub worthy. When I let U equal that inside function, and I take its derivative with respect to x, I don't get the entire integrand, but I get enough where I can fix it. Now watch, one change, Ollie, and you can't do U-sub anymore. Want to see it? Maybe if I just made that a 4. U-sub no longer is a candidate. It's not that you can't integrate it, you just don't know how yet. Does that make sense? All right, so let's go do it. We're going to go start the rewrite on this guy. We have an integral. Our U was on the bottom, and it was squared. So that's what I've got going right here. I need to replace the x squared dx only. Look at the box I'm putting it in right here. That's what needs to get replaced. So this needs a fraction correction. Of what? Negative 1/3. This is the one I had my first hour do on their own. And one of the issues was some didn't have a negative 3x squared. They sloppily wrote a 3x squared. A sign error in this process is huge because what did I tell you we're eventually going to? Areas. And you can't get negative area. So it'll be a bummer if you're finding the surface area of an oil spill, right? And you go through this whole U-sub process, you make a sign error right there and you're going to get negative surface area and you're going to go, oh no. So sign errors are deadly. What did I say? Sign errors are deadly. All right, so let's not make one. So this would become an x squared dx. All right, that's what I need to replace. So this whole box gets replaced with negative 1/3 du. Where did I tell you to put your fraction correction? Always. It'll make your arithmetic, and that's where if you use Calc Chat, I'll know, because they don't do that. They leave it inside. They do it all horizontally. It's done differently. So use it to check your final answer, because the answers are the same, but the process isn't. All right, so I've got that negative 1/3 there. Some books will put the du right here. I personally don't like it because these are eventually going to represent two very different things graphically. One of them is going to be a height of a rectangle and the other one's going to be its width. And I don't want you to see it as length over width. I want you to see it as length times width. So again, there's different ways you can write it. I think in Calc Chat they don't write this. They write it like this. I don't like that right now. I don't want you doing it. All right, so the next thing we're going to do is get that power so we can see it. All right, and then be careful because my first hour, again, another mistake that I saw is what they said the antiderivative of this is. A lot of them said u to the negative 1/3. What should it be? U to the negative 1. Yeah, you're adding 1 when you're integrating. So this is negative 1/3. U to the negative 1 over what? Negative 1, yeah, plus Carl, right? And then we'll clean it up and back substitute and be done with it. 2 parts to the cleanup. These 2 negatives will make a positive. U to the negative 1 is going to put it in the denominator. C is still there. How are we doing? I feel like you guys are getting it. So I'm not done though, Sam. Why not? You might say, I'm done. Looks good. You didn't make any mistakes. No, I did not. But it's not done. No, C should be there. Who haven't I picked on today? Harvey. It's a great question. I was kind of hoping you didn't get it. Why? It feels good. It feels like I'm done. I've integrated. I got it all cleaned up. Why isn't it done, Harvey? Yeah, this is where I would say, because some of you will leave it like this, and you'll hear me say this isn't about you, right? And this problem was about x, so you have to go back. You're using a variable change to help you integrate. We're using u because historically that's what they chose. But again, we chose b for Bo, and it worked out just fine because right here you always back substitute. So what you call your dummy variable does not matter, but please call it u like everybody else in the history of math always has. Unless, when did I say we don't call our dummy variable u? When u is what the problem's about. You're nodding, Nathan. Does this make sense? So I think you guys are ready to try one on your own. I think what I want to do, I think we're going to go to the book. Take the book out from under your desk. And your assignment is 11 through 37 odd on 306. I'm going to go have you try. And this one's due tomorrow, but I think what we'll do is jump right in the middle and try a medium plus one, and if it goes well. So I got to see which one I chose last hour. I think we're ready. How many minutes? You guys win today. 17 minutes. Well, we'll see how this one goes. And, to be honest, it wasn't my first hour's problem. I did a physics thing with them at the beginning that took up 10 minutes, and I chose not to do it with you guys. So it's not their problem. It was my fault. What was that? We're going to go to number 23 because it's got a bunch of negatives in it. We're going to try that one first. I think I'll let you work it out while I work it out, but I'm not going to talk up there. So if you're stuck, look up. When you're done, look up. If it's right, awesome. If not, find where you went wrong. What do we have? X over 1 minus x squared cubed. X over. Kellen, how are you doing? You came in late. Are you catching on? You missed kind of the important of when do I know when to use this. You might want to listen to the first 10 minutes of the notes because you kind of know how to do it, but you won't know when to use it. All right. I'm just making sure I wrote it down right before I start. All right. I'm going to do it really slow up here. Look up if you get stuck. Otherwise, don't look up at all till you get to the end, and then look up to check the answer. And then just skip this one when you get there. You don't have to box it all in like this. I'm just trying to visually show you what I'm doing. I'm running out of space. And again, if you're watching the notes, you should be doing this exact same thing. He wasn't done. Oh, you're already on to the other one. How are we doing? All right, then. I just high-fived 3 of the 4 who were done, and they were right. So I'm going to assume the rest of that was a satisfactory sample set. What I want you to do is go to number 11. Okay, you have close to 15 minutes. Use them. This assignment's due tomorrow, and I want to find if we don't know how to do it, because like I said, this is crucial skill here. Like probably the most important thing to date you've learned. We're not done with it. You might say, this is easy. There's more, but this is really important. I want you to go to number 11, and walking around Just one second, Katie. I'm almost done. With number 11, and again, if you're watching these at home, you should have the book open on your laptop and go tab it and go look at number 11, because when I was walking around the room this morning, you guys have the benefit of me knowing what's been done wrong. There were a lot of fraction corrections, not a lot, like 5 out of 25, which is, I guess, isn't that many, but there were many fraction corrections of 1/6. You might say there would be one. There wouldn't for that problem. They don't all get fraction corrections. It's really important that you understand why that one doesn't. So can somebody who gets it, why number 11 will not have a fraction correction? Why not, Nate? Yeah, the derivative of your inside function is 6dx, which is exactly the rest of the integrand. All right? If the rest of the integrand was just dx, then you need it. So it's important. You won't be fraction correctioning every single problem on this assignment, but I bet at least half of them. So watch out for it, but don't do it every problem. All right, go ahead. That one's due tomorrow. Get used to the process of showing your steps too. By the way, one last thing, don't do this part in your head. Not because it's difficult, but when we do what's called definite integrals, which means there's going to be numbers here and it's going to represent something to do with area, they need to get plugged into this stuff. So you're going to want it there eventually anyway. So get used to, some kids will put it in a box, but at least get used to defining your u and your du. I guess the fraction correction part you could do in your head, but at a minimum, get these two things written down for every problem. Those of you who are absent, I hope